Hi, today we're going to be looking at an overview of ClearCalcs Concrete Beam Calculator in US standards. At the top, you can see that we are designing to ACI 31814, and then the assumptions state shear is considered at support locations and is not offset. On the left-hand side, you can input your key properties to design your beam. You can design either a rectangular or T-beam shaped cross-section. Here, you can input your geometry dimensions. By default, we are designing a 24 by 14 inch rectangular beam that is 30 feet in length. We can also define the concrete strength and weight classification. By using a lightweight concrete, you can specify a modified reduction factor for lower tensile capacity. Alternatively, you can use a custom option if you have a more specific concrete density or lightweight factor that you would rather use. Like all of our other beam calculators, you can input an unlimited number of supports. The concrete beam calculator allows you to customize the steel reinforcement in the beam. You can add multiple rows and adjust the size of the bars. It will also check that you have enough space to allow for proper concrete flow between the bars. This assumes an aggregate size of less than 3¼ inches. For example, if we had 8 bars, based on the diagram, there's clearly not enough space at the bottom, and it will indicate here, as well as at the top, why our design fails, stating that there's not enough space between the bars. Stirrups may also be included to design for shear reinforcements at the support specifically. This section is used to calculate the steel component of the shear capacity later on. Like all of our other beam calculators, you can also include an unlimited number of loads in various locations, and you can also link it to other sheets that you may have designed using ClearCalcs. The design criteria will allow you to specify the limits for deflection. Scrolling down, we can see the moment bending capacity section. You can see the intermediate steps used to calculate the factored flexural strength. It includes a strength reduction factor, phi, which is determined based on one of 3 values as provided in ACI 31814. It is dependent on strain at the extreme tension steel, which indicates whether the section is tension or compression controlled. In the shear strength at support section, you can see the components of both the concrete and the reinforcement. These are added together in the shear capacity and reduced by a factor of 0.75 for all calculations. This is indicated in the code for concrete. In the serviceability requirements, you can see all of the calculations for deflections. It is calculated for each span individually. For cantilevers, the allowable deflection is taken as twice the simple span deflection per the IBC. Total deflection is then multiplied by the analysis to effective moment of inertia ratio. Your computed results are always updated in real time and located at the top right of the page under Summary. You can also make use of the traffic light system to see if your design capacity is passing, and below there are also dynamic diagrams that will show the reactions as well as the graph load combinations below.